Right. Question number 2. Classify each variable as categorical or numerical. What do you think, guys? Age and their gender. Age is numerical. Discrete or continuous? Discrete, right? Age. Others agree? Yeah. Why is it discrete? Can't we say like I am 16.5, 16 and a half years old? Not really, yes, we don't say like that. And not especially if the age is in years. Remember guys, that one, guys. Age is in years, we usually say discrete. Good. Then gender, categorical, what is it? Nominal or ordinal? Ordinal. Ordinal. Huh? Ordinal. Right? Gender is ordinal. Right? All of you are wrong. Right? Gender is nominal. Is there an order that male is superior or female is superior? No. Not like that. Yes. So gender is nominal. Right? We don't have an order. This is good, this is bad, this is high, this is low. No. Okay? It's nominal, it's given, it's like set, right? Okay, then part B. Do the back-to-back plots support the contention that the age of the patients is associated with their gender? Write a brief explanation. What do you think about this one, guys? Did you calculate the median? For female median, what is it? 30? 4? Yep. Q1? What is Q1? I got 15. Q3? 43 as a result. IQ is yes, 20. 8, yes. Right. Then what about the other one, guys? Males, what is the median? 20. 5.5. Good. Q1, 21. Q3, 34. So as a result, IQ is 11. Sorry, 13, yes. Yeah. IQ is 13. So then, did you get these values? Yeah, all of you are okay. If you have any problem, tell me, I can help you. Right. Then basically, what do you think here? What can we conclude? Right? So when we consider the age that they were admitted to the hospital was, excuse me, for females it's 34 and males it's 25.5, or we can say 26. And also we can see there is a high variance, high variability within females with IQ of 28. Even it is more than double that of the males, yes, which is 30. Right, so the females have a high variability, high variance in their ages with the admissions. So then we can conclude that there is association with the patients that were admitted to the hospital as it has with their age. So there is an association with the patients and their age, right? Okay. So technically, like males, they are admitted younger, right? with lower age and females, they are basically probably we can say they have a high level of age with their admission. Right. Any questions? Right. Next one, I asked you to do question number 5. Right. What do you think about this one? Categorical and numerical. What are the variables, guys? Pass rate and the gender. Very good. Pass rate again. Numerical. And then gender. Categorical. What is it? Nominal or ordinal? For gender. Yes. Yes, nominal. Yeah, don't say ordinal. Nominal. Yes. Okay, good. All right, guys. Then next one. Use the box plots to compare these distributions and draw an appropriate conclusion about the association between gender and the pass rate. What do you think, guys? Yeah, again, we'll give the values. You have to give the values. What is it for males again? Median. Or let's say female median. 76. Yep. And then Q1 is Q1 is given. We don't have to worry about it. Q1 is 68, yes. And then Q3 is 82. So then as a result, IQ-wise, we can say IQ was straight away 14. Right? IQ is 14. And then with the males, 73, yes, median. Median is 73. IQ is sorry?
6 minus 8.
It is 8. IQ is 8, correct. Right. Then guys, what can we say? The variance. So is there any association between gender and the pass rate? Yeah, so for the males, they have a lower pass rate, which is 73, against the female 76. And also their variance is lower than that of females. Why? Because the IQ is 8, and then that of women's is 14. Right? So then also we have talked about the distribution. What do you say? Are they symmetric, skewed, what? Any outliers? No outliers, and then approximately both of them are, what is it, Ma? Approximately negatively, so we can say symmetric. Yes, both of them are approximately symmetric. Okay, the next one, guys, question number 6. So is there an association here with the gender and pass rate? Yes. Okay, question 6, we have 3 box plots. Parallel box plots show the distribution of lifetime of 3 differently priced batteries, low, medium, and high. Right? Okay, so then what's the numerical and categorical variables? Lifetime is numerical, measured in hours. Yep, lifetime. The horizontal axis variable is numerical, correct? And then the other one, the price is categorical. Okay. Price. This one. Category. Ordinal or nominal? Ordinal. Ordinal. Nominal. Okay, now again, how do you know it's ordinal? Ordinal means what? There is an order, rank. So what is this? Ordinal. Yeah, this is ordinal. Right. Okay, guys. Then do the parallel box for support the contention that the battery lifetime depends on the price. Right. What do you think? Yep. What do you think? Now again, we can't just answer this question. We have to analyze the information. Yes. Let's start with the high. What is the median value? 50. Is it 51? 50? Yeah, 50. 1. Correct. She's correct. 51. Why? Because this is in between. Yeah. 50 and 52. Yeah. So 51. 51 is correct. Median, and then IQ 8. 8. Yeah. Right. Then next one, guys, median. Yeah, median. What is the median? 35. Yep. 35 is correct. And then IQ is, I would say 12. No?
Yeah.
Next one. This one median is 32. And then IQ is I would say 18. Or we can say 17.5 as well, but approximately I would say 18. Okay. Now what was the report you said? Now the question: Do you think there is a contention that the battery lifetime depends on the price? Battery lifetime depends with the price. This is the price. Yes. Why yes, Gautama? The lifetime is increasing as the price is increasing. Correct. Why? With the low price, our median we can expect around 32 hours. Medium price 35 hours. And the high price 51. Wonderful. Right? So it is 51. And also look at the variation. When you pay a high price, you can expect a very consistent, yes, small variance is there, very consistent performance can be, or consistent lifetime can be expected, right? Why? Because you have only 8 hours of IQ. And also, guys, as the price is decreasing, what is happening? Variation is also increasing. So you can't predict, right? Let's say you purchase a low price one, either you can have 24 hours or I mean, or even lower than that. You can have 16 hours or you can have 56 hours. It is really varying, high variance. Okay. Otherwise, you can say IQR is 18 for the low and 12, 8. All right, now shall we do some exam questions? Or you think you guys are okay with this? I will do the questions. Yeah, question number 7. Yeah. Are you guys done? Yeah. What do you think? Sir? A? Yeah. Gutama, reconsider your answer. Right. Okay, now we'll try the question number 8. We'll discuss when it's here. Right. Can try question 8. Paragraph. Yeah, we are in question 8. E. C. Yeah. Okay, shall we discuss?
Shall we discuss?
Now,
All right.
question
Now,
number
question
7.
number 7.
Yeah, A. I got C.
A, A,
I got C.
C. Yep. Okay, C. Now we'll figure it out. Yes. Right. Which of the following statements is true? Right. So then they have given us information about the birth rates of babies who are smoking and non-smoking families. Right. 75% of babies born to non-smokers weigh more than the lightest 50% of the babies born to smokers. What do you think about that? 75% of the babies born to non-smokers. 75% where can we see? Way more than the lightest 50%. So that means 75% is going to be from here, yep. Q1 onwards, yep. Q1 onwards, right? And then way more than the lightest 50% of the babies. The lightest 50% of the smoking babies is this one, yeah. This one has 50%. This one has 75%. Right? Both of them are in the same boundary. Is it correct? Is it true? Yeah.
Wouldn't the 75% start like at the end of the tail, like at the start of the tail?
At the start, no. They are saying, see, 75% of the babies born to non-smokers weigh more than the lightest 50%. So basically, you have to start after the lightest 50%. What's the lightest 50%? Our lightest 50% of the smokers are here. Then that's the boundary to start the 75% of the non-smokers. So you agree? Yeah, that's true.
It doesn't specify which 75%. What if it's
Yeah, because you know how it specifies. Yeah. 75% of the babies to non-smokers weigh more than. This is the specification, yeah? Way more than. If it was less than, then different story. Yeah? So 75% of the babies born to non-smokers weigh more than. So that means weigh more than. Yeah. Make sense? Good. Then C. 25% of the babies born to smokers weigh less than all the babies born to non-smokers. 25% of the babies born to smokers. 25% what we can say is here. This 25% we can say, otherwise this 25% we can say. 25% of the babies born to smokers, way less than all the babies born to non-smokers. Do you think it is correct?
Of course, of course.
No, what do you think? So the 25%, which 25% do we consider lower? In fact, it is more than 25%, yes?
Sorry.
Isn't it more than 25%? Because, well, what is the starting point of the non-smokers? It's here. Yeah? So then it should be more than 25%, not like 25% of the babies. More than 25%, yes? I would say more than 25%. Yep. So Q1 is here for the smokers. Yep. But the starting point of the non-smoker is here. So that means there is a gap. So then it is more than 25%. Right? That's why it is wrong. Yeah, so the answer, correct answer is A. Okay, guys, then question number 8. Information supports that there is an association between smoking and weight of the baby at birth. What do you think? Which one? IQR of the birth weights for both groups are approximately the same. Are they the same? Yeah. This one we can say approximately 1.5 or 1.6. This one we can say 7 to 8. No, I think this is not 1.5. This one we can say 1.7. This one I can say 1.6. Right? Yeah, it's almost similar. Just 0.1 kilo or 0.1, what is it? Pounds, yes. 0.1 kilo, 1 pound, it is a little bit different. Right, then, yeah, what's your answers here, guys? What did you answer? D. Okay. A. Yeah, approximately the same. Okay. B. Median birth weight for small. Okay, now what's the problem, guys? Right. So if you are going to say that there is an association between smoking and the weight of the baby, would we really consider the IQR or something else?
You repeat the question.
Yeah. So if you are going to assess that there is an association between the smoking and the weight, right? Which one do you really consider? IQ or something else? What is it? What is that something else? Median, correct. Median, not the mean. Median is the best. I think we discussed about that before, because mean can be may not be really reliable when there are outliers, especially. So then mean value is the more realistic or practicable or trustworthy um, uh, measurement, right? So then, in this case, we have really value. What is it, guys? Median, right? When you look at the median, do you think that the smoking and the birth weights would change? I mean, they have an association. Yes. So smoking families, they can their baby's birth weight, median birth weight is 7 pounds, whereas non-smoking it is, I think, 7.4. So then I would say, which one is in that one? Yeah, D. Whoever said D is correct. For A, Maha, this is not the same. There is a slight gap, right? 1.6 and 1.7. Okay, guys, then we are done with this. Now we are going to investigate association between two numerical variables, right? Now, what have you been doing so far? From the start, those who were with me from the start, what did we do, guys? We did, we did firstly, we did two categoricals, then one categorical, one numerical, and now this one, finally we come to both numerical, and this is what we are going to continue in the future as well, right? The numerical is what we are going to identify the associations with, right? So these associations, usually, we discuss this one, I think you guys should be fine. Vertical, in the vertical or the y-axis, we present the response variable or the which variable? Another term for that? Sorry? Yeah, for the response variable, another term. What did you learn in year 10 maths? Which variable? Dependent variable, right? If you are still struggling with the response and the explanatory, response means what? Responding to something, right? Yeah, responding. Then dependent variable, which is on the y-axis or vertical axis. Then horizontal axis or x-axis, we present the explanatory or the independent variable. Okay. Now here we need the CAS. Okay. If you don't have the CAS, you'll have to go home and practice. Right. Now, I know, I think all of you have done Unit 1, 2 years. No, you haven't done. You have ever done? Yeah. Okay, so then Maha, you haven't done, yes? That means, yeah, make sure you bring the CAS. Do you have a CAS? Yeah, make sure you bring the CAS every day, okay? Every day you need the CAS. Right. So, are you okay? Have you done this thing? Have you like kind of navigate through in your CAS? No? Okay, then don't worry. It's not that hard. Basically, you should be able to pick up, you guys are better at technology than us. So then you should be able to pick it up. Usually in my past experience, I have never had a student who is struggling with the CAS. So everybody is very good at CAS. Okay. However, guys, the steps are there, right? You have to start a new document, pressing Control button and N button, and then you can add list and spreadsheet in the thing. then you'll have to enter the data one by one. Okay, and also you have to pick the response and explanatory variable. Okay, right. So basically, then when you after having done that one, having entered all the data like a spreadsheet or Excel in the computer, then you can press Control and I. Then you can select Add Data and Statistics, and then as a result, you can pick the what explanatory and what response variables are. Then you can do the scatter plot. So scatter plot will be displayed automatically. This is the scatter plot. Okay. Right. If you have a class pad, anybody has a class pad? No. All of you are having CAS? Yeah. I mean, CAS, sorry, in the sense TI Nspire. So if you have TI, that is the steps for that. TI Nspire, and then this one is for the class pad. Right. Okay, guys. So let's go to the questions straight away. Okay, no, before that. Yeah, this one they have given the EV and RV. So then there is no actually challenge here. Right. Yeah. Okay. Read this question and answer the questions, guys. Done, guys? Okay. Now what is this scatter plot shows? Yeah. So
Association.
association between airspeed and the Number of seats, yes, right. So and what can we say? What is the explanatory variable, guys?
Number of sheets.
Number of seats is not depending on anything. It is independent, and whereas airspeed is dependent. Yep. Okay. What type of variable is airspeed?
Response.
No, what type of variable? Categorical, numerical. Categorical is airspeed, you sure? Airspeed, part B.
Oh, type of response.
No, what type of variable?
Oh,
Numerical. Categorical airspeed measured in kilometers an hour. Numerical, yes, it's numerical, right? Like, forget about the airspeed. Normal speed, how do we measure? Let's say if you are all of us are going in vehicles, yeah, what's the speed? Basically measured in kilometers per hour, yes, like numerical, yep. Then my next question, discrete or continuous? In this case, discrete, yes, right? Kilometers per hour, discrete. Right. Part C,
8.
8. 8, yeah. So there are 8 dot plots, so that means there are 8 aircrafts. D, what was the airspeed of the aircraft that has 300 seats? 800 kilometers an hour, yeah. Now, what can you say, guys, when you look at this scatter plot? Is it like, what kind of relationship is there? Positive, negative, or no relationship? Sorry? Positive, yes. Why? Because as the number of seats increasing, what is happening? The airspeed also increases, yes? Yeah. Yeah, this one part 2, as both of you don't have CAS, only he can do it. You are okay with this one, Gautama, like using the CAS?
Yeah.
Yes, okay. Have you done this one?
Not like the exact question.
You haven't tried in the CAS? You haven't either, yeah? Then you guys have to practice this one at home. All of these are with the calculator. So then, do you want to try this one, Gautama? Or you can try? You want to try or you are okay? Fine, okay. All right, let's do this question, guys. Yeah, this is a kind of theoretical question. If you're done, let me know. Huh? Okay. Right. For which one of the following pairs would it be appropriate to construct a scatter plot? So then, what's the theoretical thing, guys, to draw a scatter plot? No, I mean theory. What's the theory for the scatter plot? What for what variables should we draw a scatter plot? For the numerical. What else? Anything else? Come again? Yes. So basically, we find the explanatory and response in the numerical variables, right? So what is the answer for this one? C. D. D. We are saying C. Right. Political party preference. Right? That's what you are saying, C, yes? Yeah. So then what do you think about an AGNES? AG, what is it? Numerical or numerical? Party preference? Categorical, right? Categorical variable, right? Again, there is no order label liberal, so as a result, it will be nominal, right? So technically categorical variable. So then can we apply a scatter plot? No. Then we have to apply a dot plot or something like that, right? Sorry, yeah, dot plot. Right? Then D, age in years and blood pressure in millimeter HD, right? I don't know what mmHD is. However, I know that age is in years and blood pressure also we measure in numerical years. So then what is the answer? D. All the others, have a look. Eye color, hair color. All of them are both are categorical. Then we have to use what table that can we construct with when both of them are categorical? Bar graphs. Yes, very good. And then test score, numerical, sex, categorical. Then again we can draw a box plot. And then political party preference, again the box plot. D is the one we can draw the, what is it? Scatter plot. Remember, with the scatter plot, what's the condition, Gautama? Both the variables should be what? Numerical. Both of them should be numerical. Otherwise, we can't draw a scatter. All right, now we are going to the interpretation of the scatter plot. This is very important. I don't think we can finish this one today, but however, let's start. Right? This is very important. Okay, theoretically, very extremely important. Now, yeah, look at this. Now, we are going to assess different scatter plots based on three conditions or three features, right? So we are going to assess three features, three characteristics or conditions in each and every scatter plot hereafter. So those three things are these ones: direction, right? Form and strength. Okay. Firstly, guys, directions and outliers, of course, you know. Directions we are basically going to measure the association or the relationship, whether it is positive. Remember, I asked you a question earlier, whether it is positive or negative with the airspeed and the number of seats. All of you said positive. That means you have an understanding already. Yep, about the association or the direction. So direction can be positive. Now let's look at this one. Right? Positive. So which means increasing, going up. Then this one, what is it? Negative. Right? Now, when I was a student, I had a problem. Isn't it increasing to the left? No, not really. That's my problem. When I was at your level, right? So on the other left-hand side, it's increasing, yes? How can you figure out whether it is increasing? Then remember, guys, as the horizontal axis is increasing, that is what we are going to measure. So in this case, horizontal axis is increasing, but vertical is going down. That's why we are saying negative, right? As the horizontal axis increases or improves, what is happening to the vertical? So the vertical is going down. That's why we say it is negative. But this one, as it is going up, as it is increasing, the vertical axis also increases. No problem. Okay. This one, it's opposite. This is going down. And look at this one. What about this? Is there an association? No association. Nothing. No association. Okay. Also, in this kind of thing, you can have dot plots here and everywhere. So no association. Right. Good. Yeah. Positive going up. Negative going down. And yeah, this one. Yeah, tell me this one, guys. Yeah, now have a look at this one. Directions of an association, positive, negative, and no association. Right. What do you think about A? Yeah, negative. This is negative. B, nothing, no. C, positive. Okay. Right. Okay, guys. Next one. Form. So what we measure by the form is whether it is linear or non-linear. What do you mean by linear? Straight line. Very good. Thank you. Straight line. Linear means if we have a straight line. Now look at this one. Right. This one we can say very clearly there is a straight line. This one also approximately we can say there is a straight line. But have a look at this one. This is non-linear. This is non-linear. This is linear, linear, non-linear. Now, in this case, with the form, we don't really worry whether it is positive or negative. Now, see, this is positive, this is negative, right? So we don't really worry about that. Positive and negative is coming with the direction, right? Direction of the association. But this one, guys, form, we are looking at the whether it is straight or not, whether the graph is straight line or not, yeah? Or not linear or non-linear. The next one is, okay, questions. What do you think about A? Linear. Yeah, this one will say this is linear. B, Non-linear, yeah. This is non-linear. Correct. Wonderful. Right. Then final, the third one, strength. Right? Strength, guys. Now, with the strength, what we are looking at is actually whether, I mean, how strong the scatter plot, whether they are tightly clustered, right? Or whether it is not as tight and it is dispersed, right? Kind of, what can I say? Scattered around. Right? Now look at this one. So this one we can say, see, it is very tightly clustered. But this one, see, it is spread around. Yeah. So that is what we are going to measure from the strength. How strong the relationship is. Right? Okay. This is strong positive. This is strong positive. Right? This is negative. Strong but negative. Then this one, moderate, guys. See, it is still scattered, closely, but moderate. Moderate positive, moderate positive, moderate negative. And whereas this one, last one, weak positive, weak positive, weak negative. Okay. Any questions with this? Finally, guys, right? Now, strength is, now see what I told you, strength, strong if the points are scattered, tightly clustered about a trend line, and then moderate. The scatter plot tend to be broadly clustered, like this one. This is the moderate, and then finally it is weak, right? They are scattered around, but we can see a clear association, positive, negative, or whatever. Right. Okay, now if we have a look at this one, guys. Now, what do you think about this one?
A is moderate positive association.
Hold on. It is moderate or weak? This one? This one is moderate?
Oh, that one's strong.
Strong, yeah? This is strong. B is strong. A? Weak. I would say weak as well, Gautam, right? This is not really moderate. This would be weak. Oh, you see? It's like everywhere. No? Okay. Yeah. Weak and strong. Okay, guys, I'll give you this exercise 2E for homework. Next week, we are going to do strength of a linear relationship. I think those who have, I mean, probably you have done in year 10 maths as well. Correlation coefficient. Have you heard? Okay. Correlation coefficient? No. That means you haven't done in year 10, yeah? Correlation coefficient? This year you are starting this year, okay. You haven't done it. Correlation coefficient unit 1, 2, you haven't done. Yeah. Okay, that means this is going to be new for all of you. Correlation coefficient. Correlation coefficient means, guys, we are going to measure the strength. Now, see, we said that this is moderate, that is weak, strong, right? No association like that. For the now we have a measurement called coefficient, correlation coefficient. What we are going to measure using the CAS, right? And it will range from -1 to +1, right? So it can be -1, -0.5, 0, and up to 1, right? So -1 to +1 ranging, and then we are going to we are going to calculate it using the CAS, right? So hereafter, you don't have to really worry about, whether that is moderate, weak, and so on by looking at that one, because calculator will tell you. I mean, calculator will give you the value, but you have to rank it, which I'm going to give you the values, and then you can tell after that whether it is strong, moderate, or whatever it is. So these are the values, right? So this one we are going to do next week. So make sure you bring your CAS. Okay, take down the homework. 2E. Yeah, all of 2E. This one.